Okay, last class we went over SOHCAHTOA. We went over SOHCAHTOA. And that was the 3 trigonometric ratios for a right triangle. So remember, the sine of the angle is equal to the opposite over the hypotenuse. SOH. The cosine of the angle is equal to the adjacent over the hypotenuse. CAH. Tangent of the angle is equal to the opposite over the adjacent. TOA. So there are 3 more trigonometric ratios. Tessa, did you learn those in geometry? No. Okay, so there are 3 more trigonometric ratios, and I'll write out their names and then I'll write their abbreviations like I did last time. So the first one is called cosecant. And the abbreviation for cosecant is CSC. We always do that of an angle. And the cosecant is hypotenuse over opposite. The next one is called secant. And secant is abbreviated SEC. We do that of an angle. And that is hypotenuse over adjacent. And the third one is called cotangent. And cotangent is COT of an angle. And that equals adjacent over opposite. So if you look really carefully, can we see how sine, cosine, tangent are related to cosecant, secant, and cotangent? Can anybody notice? Nina? They are flipped. They are reciprocals. These are the reciprocals of the main 3 functions. So these are just reciprocals. I'm writing it sideways. Reciprocals. Okay? When you reciprocate them, they have a new name. But if you have SOHCAHTOA memorized, and you can take 2 numbers and reciprocate them, you're good, because that's all these are. The thing that makes it a teeny bit tricky is you just got to remember which one goes with which. I think remembering that tangent and cotangent go together, that one I think we can figure out. Tangent and cotangent. It's the other 2 that people sometimes mess up. So I have a way to remember that sine and cosecant go together, and that cosine and secant, they are reciprocals of each other. So in each pair, in each of these pairs, there is only one CO in each pair. Only one CO per pair, per reciprocals per pair. There's only one CO per pair. So sine has to go with cosecant. Cosine goes with secant. And then tangent and cotangent go together. Do you see what I mean by only one CO? Sine and cosecant, cosine and secant, and then tangent and cotangent. Do you guys see what I mean by one co? So cosine and cosecant do not go together. There's two cos there. So one co per group. So let's find the 6 trigonometric ratios for the specified angle. So we did sine, cosine, tangent last time. So we'll start out with sine, cosine, tangent. We're going to say, we're going to say sine, come on. We're going to say sine theta, cosine theta, tangent theta. We're going to find the 3 trigonometric ratios, and then we're going to use those to find the other 3. So sine is, Amar, what is sine? What over what? Opposite over hypotenuse. There's a right O over H here. So sine is opposite over hypotenuse. And we will know which angle to use because it is marked as theta. So we use theta and we go to the opposite of theta. The opposite doesn't touch it, 16. And then we put that over the hypotenuse. But Ryan, what's my problem? I don't know the hypotenuse. So I've got a couple choices. I could use Pythagorean theorem, or I could see if it's a triple so I have a shortcut. So I'm going to check triple first because 12 and 16 are kind of nice numbers. So 12 and 16 both have a 4 in common. This would be like 4 times 3, and this would be 4 times 4. Do we have a triple that has a 3 and a 4 in it? What's the third side of a 3, 4? 5 triple. So this one would be 4 times 5, which is 20. Okay, if that totally went over your head because you didn't understand how to use triples, then use Pythagorean theorem, which is a squared plus b squared equals c squared. I'm not doing the whole thing, but 16 squared plus 12 squared equals, and so on. Okay, so 16 over 20. Then we say, does that reduce? Yeah, it does reduce. It reduces to 4 over 5. Now, isn't that interesting that it reduces to the original triple, 4 and 5? Isn't that interesting? The 4s, the times by 4s canceled out. Cosine. Cosine is, Emma, what's cosine? Adjacent over hypotenuse. Excellent. So we're going to look at our theta, and adjacent to theta is 12. Hypotenuse is 20. We're going to reduce that. They reduce by 4s, and we get 3/5. Tangent. Sierra, what's tangent? Opposite over adjacent. TOA. So our opposite is 16. Our adjacent is 12. We reduce those by 4s, and we get 4/3. Now we have the new ones. So now we have cosecant that goes with sine. Cosecant, just take sine and flip it. So Brooke, what will be my cosecant? 5 over 4, done. The next one, cosine, goes with secant, S-E-C. Before I go on, do you guys notice how I write theta every single time? Okay, I'm going to tell you right now, that's not me just going above and beyond. That's what you have to do because you never, ever, ever have secant by itself. It's always secant of an angle. And if you don't realize those go together and you don't practice those going together, it's going to hurt you in the future. So we want to make sure we're always writing that angle there so that you know that they are never by themselves. They're always with the angle. Okay, secant would be Tessa. 5/3, excellent. And then tangent goes with cotangent, which I call COT. And Jackson, what's a cotangent? 3 over 4. See, that's all we added on was flip, flip, flip. All right, we got one more example of these. So we're going to do the sine of theta, the cosine of theta, the tangent of theta, and then we'll flip. Hello, Jacob. I said this last time if you weren't here, but if you're in trig next year, your entire first semester is basically doing this stuff. So it's a pretty big deal, just why we're not just skipping it at the end of the year. And then if you're in pre-calc next year, then 3 months of your first semester is doing this stuff. So everybody's doing a ton of this next year. It's pretty important that we don't just skip it. But I hope you see it's not that hard, so that's good. Okay, so sine is, Ari, what is sine? No. The formula. Opposite over hypotenuse. So in this picture, do we have the opposite? Opposite does not touch theta, so that's the one we don't have. So the first thing that I'm going to do is I'm going to see if it's some sort of triple. So 15 is like 5 times 3, and 20 is 5 times 4. Is that a triple? Is that a triple? Ashlyn? Yes. Well, what would the other side be? 25? Okay, before I go on, there's something wrong with that side being 25. Jacob?
It's 25 should be the hypotenuse, so isn't it right? It's too long.
The longest side should be the hypotenuse. And in this picture, 25 doesn't end up being the hypotenuse. So the fact that there's a 3 and a 4 there, it could be a triple except for where the 3 and 4 are located. You see what I'm saying? So we can't just go by, oh, there's a 3 and a 4, it must be 3, 4, 5, because as soon as I put that 5 in there, that can't possibly be right. So this one is not a triple. So we will have to use Pythagorean theorem, and we are missing one of the 2 legs. It doesn't matter if it's A or B. So I have like 15 squared plus B squared equals 20 squared. So we've got 225 plus B squared equals 400. B squared equals 175. Is that a perfect square? No. But does it simplify? We learned that in chapter 5. Does it simplify? Is there a perfect square that goes into 175? What? 25, yeah. How many times? 25 times what? Think quarters in $1.75. 7. So then we've got 5 square root 7 for our missing side. 5 square root 7. So I'm going to go ahead and put that up in the triangle. So going back to sine, sine is 5 square root 7 over the hypotenuse of 20. Ooh, that does reduce, doesn't it? 5 square root 7 over 20. The 5 and the 20 can reduce. Let me zoom in a little bit. So the 5 and the 20 can reduce. We get square root of 7 over 4. So that's our sine. Amar? Yeah. What if the hypotenuse was 5 times 2?
No.
Oh.
The length versus 5 rather than 7. Could that be 5 times 2?
Could it be 5 times 2 is what you're saying?
Yeah.
Well, there isn't a 2, 3, 4 triple. Is that what you mean?
Yeah.
Like it would be a 2, 3, 4. There isn't a 2, 3, 4 triple. So the first worksheet that we did for this chapter, the triples, those are the triples. Okay. So 3, 4, 5 is a triple. 5, 12, 13 is a triple, but there isn't one that's like 4, 5, 6 or something. Like it's only the ones on that worksheet. Okay. Just a random side note about triples. One reason why I gave you that just is to save you some time if they are triples, but also on the ACT, there's lots of geometry questions, and a lot of times on the ACT, they're ones with triples. And ACT is all about how fast you can do it and correct. But it's a speed thing. So if you know triples, then you don't have to do Pythagorean theorem, and that saves you time. So those are really helpful to know for the ACT too. If you don't know them, you can always use Pythagorean theorem. So I'm not like gonna test you on knowing them. It's just for your convenience and ACT. All right, so going back to cosine, Amar, what is cosine? Whatever what? Adjacent of our hypotenuse. Okay, so we do the adjacent, which is touching theta, 15, over the hypotenuse, 20. That does reduce to 3/4. And then our tangent. Aya, what's the tangent? Good. Opposite over adjacent. So our opposite, we've already said, is 5 square root 7. Our adjacent, we've already said, is 15. That does reduce to square root 7 over 3. Okay, now we got to do the other 3. Sophie, what of the 3, which one goes with sine? Cosecant, right. So it's the C or CSC. So we're just going to take sine and flip it. But as soon as I do that, I have a teeny tiny little problem. It's just a small problem. Does anybody know what's wrong with this guy? Jacob, what's wrong?
There's a radical in the denominator.
Right, we can't have a radical in the denominator. We have to get rid of the radical in the denominator, so we're going to do what's called rationalize it, which we did in chapter 5. Multiply the top and the bottom by something that will make it a perfect square. So we get 4 square root 7 over 7. So that's our cosecant. Warren, what is the reciprocal of cosine? Secant. So SEC, theta, and we just flip 3/4. So now we got 4/3 done. Ella, what is the opposite of tangent, or the reciprocal of tangent? Cotangent. COT, theta. So we flip it and we get 3 over square root 7. Am I done? Nah. So we're going to rationalize it. We'll multiply by square root of 7 over square root of 7. And we get 3 square root 7 over 7. In today's assignment, I'm not going to make you do all 6 a bunch of times. It's only going to ask for 1, and we'll do some practice questions that are like that. So, I mean, I could make you do all 6 to really memorize them, but I don't want to give you that much work. So you guys just got to make sure that you're getting them memorized, which ones go together. As long as you have SOHCAHTOA memorized, you just have to flip, flip, flip for the other 3. All right, and then the last thing on this page of notes is just some vocabulary, because I'm going to be using terms like this, and we need to know what they are. So we next are going to take an XY plane, a coordinate plane, and we're going to have an initial side, which you'll see I'm going to always put in blue. We're going to start at 0, 0, and we're going to have an initial side of an angle. Initial side means like the start. it's always going to start in the same place. It's always going to start there on that positive x-axis, always. And then we're going to have something called a terminal side. And a terminal side, terminal means like ending. It's going to stop. And those two sides together make an angle, which is what we're actually doing right now, angles. This red arc is showing from the initial side direction and how far the terminal side rotated before it stopped. So we've got initial side, terminal side, and then the arc that shows where and how far it rotated. An angle is in standard position when its vertex is at the origin. Its initial side lies on the positive x-axis. So the other word here is vertex, but that's just the origin. That's just that, end of the angle. It's always going to be at the origin for what we're doing today. So standard position starts on the what? I just read it. Standard position starts on the what x-axis? Positive x-axis. The initial side is always on the the initial side is always on the what? The positive x-axis. Same thing we just said. And then the terminal side is the ray that rotates. Now, positive angles and negative angles. Positive angles rotate counterclockwise. Counterclockwise. So from this initial side, positive rotate counterclockwise, which is going to go up first. Okay, since we're starting here horizontal, if you go up first, that's positive. That's counterclockwise. Negative angles will rotate clockwise. So if we have our initial side, negative ones will rotate down. So you don't even have to know how a clock works. If it goes up right away, it's positive. If it goes down right away, it's negative. And then here's some pictures here that show you the exact same thing. If we're going up, then this is a positive angle, positive theta. If we're going down, then theta is negative. So we're going to have positive and negative angles. Okay. Other set of notes. Okay, this is exactly how your assignment's going to be set up as well. So I'm going to do this exactly like I would do the assignment. The first section says that we are going to draw the angle with a given measure in standard position. And we're going to pick a point on the terminal side of the angle and then draw a right triangle formed as you graph the ordered pair. Write the acute angle formed with the terminal side and the x-axis. The angle will always be positive. Lots of stuff here. First thing, we're going to draw the angle in standard position. So I right now look and say, all right, we're going to have my initial side right there on the positive x-axis. That was really messy. On the positive x-axis. That was even worse. Okay. Then I look at my angle and I see, ooh, it's negative. So this is always going to be 0 degrees where you start. And if we go negative, we're going to go down. How far is this next line? 90, but we're going negative, so I'm going to call it negative 90 degrees. And then when I go halfway around, how many degrees is that? In this case, it's going to be negative 180 because we're going negative. And then the next 90 will be negative 270. And then when we go all the way around once, that'll be negative 360. So I'm just counting negatives instead of counting positives, but the actual measurements are going to be the same. Okay, and then we have to go negative 105 degrees. So that's telling me I'm going to go down. And I see where negative 90 is. I see where negative 180 is. So approximate where negative 105 would be. Maybe here. Maybe there. Okay, now I put a dot there because I know what we're doing next. So the next thing it says is we're going to, I don't know what it says exactly. Actually, wait a second. Before I do that, I forgot to draw my arc that says which direction I went. So I changed my color to red. You don't have to follow my colors, but this is how the notes looked. This is how my answer key is going to look. So I rotated in red. So now what we're going to do is we're going to look at the end of our terminal side as an ordered pair. You will not know the numbers of that ordered pair. All I know is that it's X and Y, and I'm just going to go a teeny bit more specified. If I were going to start at 0, 0 and graph this ordered pair, I would be going negative X, negative Y. Right? In the third quadrant, negative, negative. So what you do is you pretend you're graphing that. You're going to start at 0, 0, and I just changed my color, by the way, and I'm going to go negative X, negative Y. I'm going to draw that. And that makes a right triangle. In this right triangle, how did I word it? I said, find the angle formed with the terminal side and the x-axis. The angle with the terminal side and the x-axis is right here. I'm going to call it theta. It's always the terminal side and the x-axis. I just called that theta. And we're going to find that measurement. So now we can use our brains a little bit. We know the whole way to the x-axis is 180. I'm not going all the way. I'm going 105 degrees, but the theta is like what's left to get to the x-axis. So to get that theta, I'm going to take 180 degrees and I'm going to subtract off 105 degrees. So to get theta, 180, take away 105, what do we have left over? Huh? 75 degrees. So this is what we're going to do for this first section. I'm going to go a little bit faster through them. Make sure that if you feel like, oh, I totally get this, then try one on your own, but I'll give you a moment to try it once I've done a few more examples. All right, so the next one, I'm going to start, and I'm going to look at the angle. Oh, actually, I'm going to put my initial side. Oh, this is thin. That's why I was having trouble. There's my initial side, and then I look at the angle. It's 125. So that's positive. So we're going to go up 125 degrees. So if you need to, we can label the axes. So we got 0, then we've got 90, then we've got 180, then we've got 270, and then we've got 360. Just label those axes, and we're going to go 125 degrees. So that's somewhere in the second quadrant. And then I'm going to draw that red arc that shows where I rotated and how far I went. At the end of my terminal side is an ordered pair that says negative x, positive y. All of these things that we're doing are going to be helpful for what we're getting to. So the fact that I keep writing negative x, comma y, rather than just xy, or that I'm writing it at all, it's because I can tell the future and I know what's coming. And I'm trying to make what's coming easy for you. So from here, we're going to start at 0, 0, and we're going to go negative x, positive y, and that's my 90 degrees. Just like we're graphing the ordered pair, negative x, positive y. The theta connects the terminal side and the x-axis. The terminal side and the x-axis. Terminal side and the x-axis. You can see where I put my theta. And then we're going to find the measurement of that theta. So it's 180 degrees to the x-axis. I rotated 125 degrees. And what's left will be my theta. So 180 minus 125 is 55. Okay, next one is negative 215. I'm going to start. I've got my initial side on that positive x-axis. I notice this is negative, so I'm going to start with 0 degrees, negative 90, negative 180, negative 270, negative 360. I'm going to go negative 215. So if I go negative 180, that's halfway. I've got to go further than that. Negative 215, maybe somewhere up here. To get there, we pretend like we're graphing the ordered pair. I would start at 0, 0, and I would go negative x, positive y. I would start at 0, 0. I would go negative x, positive y. And then you can see where my square went. My theta is the angle that connects the terminal side and the x-axis. Okay, so we literally just did one that looks like this, but how I find theta is going to be different for this one. We just did one in the exact same quadrant, but because the first one was positive and the second one's negative here, it's slightly different. You see my red arc and my theta are kind of overlapping. So what I'm going to do to find theta for this one is I'm going to take the 215 and I'm going to subtract 180 away from it. So that's going to give me that part that's overlapping. So that one would be 35 degrees. Yep.
How would the 215 just turn positive?
Oh, you mean when I did subtracting?
Yeah.
I just thought it'd be easier to just use positives because it's an amount of 215. At that moment, it doesn't matter if it's negative or positive because the negative is direction. So it's like an amount of 215, like how much do I have? Okay. If you wanted to do negatives, nah. If you want to do negatives, then you'd have to be like negative 215 plus 180. But then this answer that I'm putting in a box every single time has to be positive. The number that I put in the box, and I think I said it in here. Did I say it in here? Yes, the last sentence, the angle will always be positive regardless of direction. So direction doesn't matter for that angle. It's inside of a triangle, it will be positive. All right, last one is 30. So I'll start with my initial side. And you know what? I probably don't need to label all of these angles this time, I hope. I'm doing it for funsies, but I probably don't need to because we're only going 30 degrees. I'm only going 30 degrees. So that's in that first quadrant still. I'm going to start at 0, 0, and I'm going to make the triangle. Oops, this will be XY. Positive, positive. So I'll make my triangle that starts at 0, 0. I go to the right, and then I go up, which makes the 90 degrees. And then my theta is inside of the triangle that connects the terminal side to the x-axis. And how much is that theta? How much is that theta? Isn't it exactly the same amount that I rotated? It's like the exact same amount that the red little rotation, they're the same. So how much is theta? 30. It's just 30 degrees. Okay, so that's the first part of your assignment. So the second part of your assignment has some vocab in it that I didn't tell you yet, but we just learned how to do it. So we're going to sketch a graph and we're going to find the reference angle. So the reference angle is formed by the terminal side and the x-axis. It's always positive and it's always acute, which is between 0 and 90. So what we just did on numbers 1 through 4 in pink was finding the reference angle. I just didn't give you what it was called yet. So now my next section is saying, find the reference angle. But it's not set up for you. Now, eventually, you won't necessarily even need a picture to find the reference angle. But for this time, we're going to sketch it. So we're just going to sketch real quick, 135 degrees. So we've got 90, we've got 180, somewhere in between that. So do the exact same thing I just did. That's all. Exact same thing. It's different vocabulary. So I'm going to start at 0, 0. And I'm going to make that triangle as I graph XY or negative XY. So you see how the 135 is not inside the triangle? I need to know the part that's inside of the triangle. Together, they make 180. So I'm going to do 180 minus 135. And we get 45 degrees. It's acute. Between 0 and 90, it's positive. So number 6, negative 250. So negative 250 is going to go down and around. I'm going to draw my triangle. My theta has to connect the terminal side to the x-axis. This time, the red arc and the theta overlap. So it's different than what we just had. So I'm not going to find the number exactly the same. My answer has to be between 0 and 90, and it has to be positive. So if I take 250, and it doesn't matter about negative or positive at this moment. If I take 250 and I take away the bottom half of it, that 180, then I get the piece that's left. Which is 70 degrees. And the more somewhat accurate you draw these pictures, the more you'll be able to look at your answer and be like, that seems like it could be right. If you got 20 degrees, that would be wrong. If you got over 100 degrees, why would that be wrong? It's not acute. Acute means it's less than 90. So we've got these 90s set up there. We've got the X and Y axis that make 90s. So it has to be less than that. All right, next one's negative 300. Do you want to try it by yourself? I think you should try these two by yourself. Try those two by yourself. You said like 8 examples. Try those two by yourself. Or is it 6? Maybe 6 examples. 6 examples. As you're trying it by yourself, if you have a question, ask me. Okay, you didn't draw your triangle correctly. Where's your terminal side? No, that's the initial side. So we're going to negative 300. So where's the line that starts at 0, 0? Yeah. So make sure you draw that terminal side because that's going to help you form your triangle correctly. And then your triangle, you start at 0, 0 and go like that spot. But, yeah. Right. So that's that you like go around that way. We're going to go 0, 0. Yeah. No. How do you grasp in order? Start at 0, 0. Put your pen at 0, 0. And then you go X. You always go X first. So we're trying to get to this one here. Yes. So you go like X, Y to get there. Okay. Yeah. Hold on. You're doing 300. You just drew 360. So 300, your arc's going to stop at the blue line. And you are going to have to subtract something, but your arc is in the wrong place. Yes. Yes. Okay, I definitely didn't make it all the way around the room, but I want to make sure that you guys have the correct way of doing this. So again, I always start by putting that initial side in there and then noticing if I'm doing positive or negative. So these are negative. So I'm going to go down, negative 90, negative 180, negative 270, negative 360. So I'm going to arc around. I'm going to go negative 300. That's going to end up in this first quadrant. And then I put a dot because that's the terminal side. That's where we finish. That's why I put a stop right there. Okay, so oh, and I forgot my angle about which direction I rotated. There we go. I rotated around and stopped. Where I stopped becomes XY. That point is XY. And then I saw people graphing the triangles incorrectly, so I want to make sure that you understand to graph the triangle, you got to go from 0, 0 to XY the way we always graph ordered pairs. So I start with my pen on 0, 0. Then I go X, and then I go Y. So down here, this is X, this is Y. Just like you graph an ordered pair. My pen draws it like I'm graphing an ordered pair. That's where your triangle is going to go. And then your theta is inside of the triangle, connects the blue terminal side to the x-axis. So together, my red arc and my theta equal 360 degrees. Together, they make a whole circle. So I'm going to do 360 degrees, take away 300 to find the difference between the two, which is 60 degrees. That's how far theta by itself would be. So 110, draw your initial side. 110 degrees is positive, so I'll go ahead and label these. 90 degrees, 180 degrees, 270 degrees, 360. I don't even need to go that high, but that's okay. And I'm going to rotate 110, and I'm going to do it positive, so it's going to go past 90. And that's where my terminal side stops. So to graph to this ordered pair, which is negative x, positive y, to graph to that ordered pair, I start at 0, 0, and I go negative x. Then I go positive y. Oops, missed. So that's negative x, that's positive y. That's how I'm making my triangle. My theta is inside of the triangle, connects the terminal side and the x-axis every single time. It looks like theta and the red 110 degrees together make 180. They're a linear pair from geometry. So if I take 180 and I subtract off 110, I will get what's left over, 70 degrees. Okay, I'm going to pause the video. I want you guys to actually try these. I'm going to walk around and pause the video so it doesn't like just keep recording nothing. All right, so 190, we draw. We start at 0. You are going to rotate past 180 just a little bit and draw our terminal side. When you get that terminal side, put a dot because that's where we stop. To get to this dot, I would have to graph negative x, negative y. That's how we get into the third quadrant. So I'm going to start at 0, 0. I'm going to graph negative x, negative y. Negative x, negative y. That's how I get to that spot. That's where my triangle is. Theta is inside of the triangle, and it connects to the x-axis and the terminal side. So then I say to myself, to find how big theta is, I'm going like 190 that way, but theta is just this little part. Forgot what I had on. Theta is just this little part right here. So how far past 180 did I go? That's 190 minus 180. That's just 10 degrees. If you got an answer like 80 degrees, your approximate graph should tell you there's no way that could be 80 degrees. Yes?
I thought you said, like, I got this answer, but then I thought you said you can only do, like, when you're doing subtraction, you can only do, like, 80 and 360. Or do you mean, like when you said that?
Because some people were using 270. I don't mean the top number.
Oh.
Yeah, I don't mean the top number. I'm just, when you use numbers, you're using 180s or 360s or 0. But some people were using 270 or 90, and we don't use those We just use the x-axis for when we're finding the differences. Okay, number 10, 240. So I've got my initial. I'm going to go around to 240. That gives me my terminal side in the third quadrant. The third quadrant has negative x, negative y. To get there, I start at 0, 0. I go left, down. Negative x, negative y. Inside of that triangle is my theta. So I went 240, but I need to go backwards so I can find the difference between 240 and 180. That's what I'm trying to find. The part between 240 and 180. So subtract those and we get 60. Negative 130. So I'm doing negative this time. So negative 130. When I get to this xy, it's going to be negative x, negative y. I start at 0, 0. I go left, down. My theta has to connect to the x-axis. Has to be on the x-axis and the terminal side. So for this one, if I'm looking at 180, it's going to be less than 180. It's going to be 180 take away the red part, the 130. Oopsies. So this one would be 50. And then the last one, 300. $300 is almost all the way around because 360 is all the way around. That's going to give me a terminal side that's positive x, negative y. If I were to graph it, start 0, 0, positive x, negative y. My theta will be between the x-axis and the terminal side. So that has got to be 360, take away 300. So 60 degrees. So I'm not going to be able to do the rest of these, but I'll just do a few of these. This won't be too bad. This one right here won't be too bad. Okay, so question 13 has given the ordered pair at which the terminal side is. It's given the ordered pair. So let's draw the triangle to graph that ordered pair. So we start at 0, 0, and we go negative 12, negative 16. Then I draw my theta in the same place we've been drawing the thetas. So I have a right triangle. The sides are negative 12, negative 16. Is 12 and 16 by any chance a triple? Otherwise, I got to do Pythagorean theorem. So 12 would be like, and I'm just looking at 12. I'm not looking at the negatives this moment. 12 would be 4 times 3. 16 would be 4 times 4. Could this one be 4 times 5? Yes, yes, because that would be the longest side of 20. Now, if I do Pythagorean theorem and I do negative 12 squared plus negative 16 squared equals c squared. What happens when I square a negative? What happens when I square a negative? Positive. 144 plus 256 equals c squared. So regardless of what the signs are for the triangle, the third side will always be positive. The third side, the hypotenuse will always be positive. Because anytime we do Pythagorean theorem, we're going to have positive numbers. Remember, the negatives are just telling you what quadrant it's in. It's not really how long the line is, because the line can't be negative 12 long. It's 12 to the negative side. Okay, so this is telling us to find the secant. So now we just learned about these today. It's a little rusty, I'm sure, but which one is the secant, the reciprocal of? Cosine. So we know that cosine is CAH. Cosine of theta is A over H. That means secant is H over A. So we're going to find the hypotenuse and put it over the adjacent. Oh, we already found the hypotenuse. It's 20. And put it over the adjacent. So 20 over, now I need to know which one is the adjacent. It's not just 12 though. What is it? It's not just 12. It's negative 12. And then we reduce that and we get negative 5/3. Did I reduce it? Yeah, negative 5/3. So we're going to keep the sign plus minus signs for when we do this trigonometric ratio. Okay. Let's do tangent. Tangent theta. So they've already drawn it for you. You just have to form the triangle. To form the triangle, we start at 0, 0. We graph x, then y. We graph 2 on the x and then 2 square root 3 on the y. What is tangent? Tangent is what over what? Opposite over adjacent. Oh, I forgot to put my theta in there. So theta, remember, is the terminal side in the x-axis. It's always there at the origin, and it's not the 90 degrees, so it's got to be that one there. So now I do the opposite over the adjacent. I get 2 square root 3 over 2, which reduces to square root 3, and we are done with that one. So we are doing trigonometry, SOHCAHTOA, but we're combining it with this reference angle concept that we spent a lot of time at the beginning of class. Well, let's see the next one. Let's not do the next one. It's cosine. Let's do a harder one. Cotangent. Let's go do cotangent. So they've given us the terminal side at 17, 13. So I'm going to start at 0, 0. I'm going to go to the right 17 and up 13. So to do cotangent, I have to know what tangent is. We just went over tangent theta is opposite over adjacent. So cotangent theta has to be, Ryan? Adjacent over opposite. So, oh, I forgot my theta again. The theta connects the x-axis and the terminal side. So adjacent to theta is which number? Anybody? Say it louder. 17. And opposite of theta is 13. Thanks. Okay. So our answer is 17 over 13. Let's do 18 because that's one of the new ones also. Okay, so they've given us the picture. We're going to start at 0, 0. We're going to go negative 15, positive 15. Negative 15, positive 15. My theta connects the terminal side and the x-axis. We need to find cosecant. Which one is cosecant flipped? Which one? What? Oh, there's no sinning in math. What is it? Sine. It's sine. So sine theta is opposite over hypotenuse, but I'm not using that one. I'm using cosecant, which is hypotenuse over opposite. I don't have the hypotenuse. How can I find it? How can I find it? Ashlyn? Did you say Pythagorean theorem? Okay. Yeah, we could use Pythagorean theorem. Okay, so Pythagorean theorem would be 15 squared plus negative 15 squared equals c squared, because remember the hypotenuse is c. So 225 plus 225 is c squared. So c squared is going to give me 450, thanks. Quick math. So when I square root that, 25 can come out of that. How many times? Ooh, then there's a bigger number. How about the fact that when I'm erasing 450. How about the fact that when I got 450, I did 225 times by 2. How about that? Isn't that how I got 450? I did 225 plus 225. And isn't 225 a perfect square? 15 squared. So this is 15 square root 2. Which should sound really familiar, I hope, if you did your last assignment, because 15 square root 2 and 15s, that's one of those special triangles. Which triangle has the two sides that are the same? What is it? 45, 45, 90. I already know what the angles are, not that it matters, but anyway. So if you had realized that 15 and 15 were the sides, you could have just skipped to 15 square root 2. All right, so now we have our hypotenuse. So I'm going to put in 15 square root 2 over our opposite, which is positive 15. And we reduce that, and we get square root 2 for our answer. Are we okay on this? We're going to do a couple more of these, but it's a little bit different because they don't give you ordered pairs in the last ones. Okay, and the last ones, it's saying you need to find the reference angle, and then we're going to do what we just did, but they should all be the special ones. Okay, so let's go through and find our reference angle for this one. I'm going to put in a dot at the terminal side, and then I'm going to find my reference angle by going x, negative x, y. And then I'll put in my theta. How many degrees is theta? Maybe I shouldn't even put theta there. Maybe I'll just write the degrees in there. How many degrees is theta? What is it? 45. All of these will be 45, 30s, or 60s, the ones that you practiced last time. All of this section will be. So if it's 45, then what we do is we pull out our formulas. And we do a square root 2, except for this one has to be negative because this is negative x, positive y. So we pull out our formulas and we check negatives. It says to find the sine of that angle. So we're going to find the sine of theta. So we're looking at the triangle. The sine is what over what? Formula. Sine OH. So I look at my 45 degrees here, my theta. This is my theta. And opposite is A. Hypotenuse is a square root 2. The a's reduce, so we get 1 over square root 2. I'm not satisfied with that answer, so I'm going to rationalize it. Multiply by square root of 2 over square root 2. And I got square root 2 over 2. Okay, look at number 20. We're doing the cosine at 210. So I'm going to draw my point. That's going to be negative x, negative y. So from there, I'm going to draw my triangle. I'm going to start at 0, 0. I'm going to go negative x, negative y. And then I have to figure out what angle is my theta. And in this section alone, it's going to be 30, 45, or 60. So if you get an answer that's not those, you're doing something wrong. So this is what we were doing at the beginning of class. What is that theta? What is that reference angle? Brooke, did you get it? Can you get it? Did somebody tell you 60 and you said it? Oh, okay. I thought I heard noises over there. It's not 60 because 60, like this is 180 here, and this is 210. It's going to be 30, okay? So this is a 30, 60, 90 triangle. I'm going to put in the formulas that we learned last class. Across from the 30, the shortest side is n. The longest side, the hypotenuse, is what? 2n. And then that third side is n square root 3. Before I go on, I didn't do everything correctly here. Does anybody know what I did? It's not like wrong, but I didn't finish. Ashlyn? We need some negative signs. So when I wrote negative x, negative y, that's a reminder to me that this is negative and this is negative. So that's why I'm writing those, to remind myself that I need negatives on the sides, or you're going to have the wrong answer. So what do we have to do? We have to do cosine. Cosine is a over h. So I need the adjacent to the theta, to the 30 degrees. What's next to the angle? Quickly, what's next to the angle? It's negative n square root 3. And then the hypotenuse is 2n. The n's will cancel out, and you're going to notice they're going to cancel out every single time. And we get negative square root 3 over 2. Okay. I didn't get to the other 4. I think what I'm going to do is just fill those out really fast without talking and just keep recording the video. And then I'll get you guys your passes. This will only take me a couple of moments. Okay? Your assignment is a worksheet. Just one worksheet.
I still need to take my tests from last week, but I don't want to go over time and MSH. So could I take it after school sometime this week? I can't do today, but I could do Thursday or Friday.
Thursday.
Okay.
Just go.
God.